This lesson is compute the determinant. Here we have another example of a 3 by 3 using cofactor method, cofactor expansion method. So I'm rewriting this matrix down here using the cofactor expansion method. We're going to start out using the 0. So we're going to put 0 over here. Again, you can use any rows, okay, columns, any rows, columns, and the result will still come out the same. For the sake of this video, I'm just going to use the first row. So 0 over here, since this is the first term, it will be positive. So 0, block up the first row, block up the first column, and all I see is -3, 0, 3, 1, which is here. Okay. Next, I will use the 4 over here. Since this is positive, the next one should be negative. So 4 over here, block up the first row, block up the second column. I have 5, 2, 0, 1, which is here. Next, I have number 1, so I'll put 1 here. Since this is negative, it will be positive. So 1 here. Block up the first row, block up the third column. So all I have left is 5, -3, 2, 3, which is here. Okay. Since this is a 3 by 3, I should have plus, minus, plus. If this was a 4 by 4, it would be plus, minus, plus, minus. Okay. Again, I'm using row 1 to block up and then every other columns. Again, you can use any rows and it will still come out the same. Again, you can use any rows and column and the answer will come out the same. For this example, and I'm just going to use the first row so that you can see what cofactor expansion method looks like. Okay. After that, you just simplify. And as you can see, 0 times everything will just end up 0. So I'm not going to do the determinant for this one because 0 times this will just be 0. Bring down the -4. Determinant of 2 by 2, A times D, so 5 times 1, which is 5, minus B times C, so 0 times 2 gives me 0, plus, bring down the 1, 5 times 3, 15, minus -3 times 2, -6. Simplify a little bit more. 0 is just 0. This gives me 5, so -4 times 5 is -20. This right here, negative times negative, gives me positive 6. Positive 6, and then 15 plus 6 will give me 21. And then after that, we simplify again. -20 plus 21 gives me positive 1. So this determinant, this matrix 3 by 3, the determinant is 1. Okay, so that is cofactor expansion. Again, you can use any row to start. You don't have to start with row 1. You can use row 2, you can use row 3. Okay, it will still come out the same solution. Okay, I just use row 1 so that you can see what cofactor expansion is. So put the 0 here, put the 4 here, put the 1 here, and then after that, block out the first column, block out the second column, block out the third column. Okay, and don't forget, always start with plus, minus, plus. Okay, if this was a 4 by 4, plus, minus, plus, minus. Okay, next, the basket weaving. Okay, so same thing, basket weaving only work for 3 by 3. So take the first column, bring it to the right side, take the second column, put it on the right side. So first column here, second column here. Just copy and paste to the right side. Start on the left, so 0, -3, 1. if you multiply 0, negative 3 times 1, that's the 0. 4 times 0 times 2 is still 0. 1 times 5 times 3 gives me this 15. One more time. 0 times 3 times negative 3 times 1, 0. 4 times 0 times 2, 0. 1 times 5 times 3, 15. Don't forget the minus. Okay, don't forget the minus. Now you did the left. Now go to the right. So 1 times negative 3 times 2, negative 6. 0 times 0 times 3, 0. 4 times 5 times 1, 20. Okay, again, 1 times negative 3 times 2, negative 6. 0 times 0 times 3, 0. 4 times 5 times 1, 20. Now let's simplify this. 0 plus 0 plus 15 gives me 15. Negative 6 plus 20 gives me positive 14, but there's a minus in front, so that gives me negative 14. So 15 subtract 14 gives me positive 1. And as you can see, co-expansion method and basket weaving give you the same result. Be very careful. Basket weaving only work for 3 by 3. Only 3 by 3. Okay? Next, we will do row operations. Okay? We will do row operations so that it is an easier, it's not an easier, but just the best method. Okay? Now, with row operation, we have a little problem here. This is a 0. Okay? We cannot have a 0 here. You can have any number you want, but that cannot be a 0. So what we're going to do is we're going to column swapping. So all I'm doing is I'm just going to swap column 3 and column 1. I'm just switching them. One more time. When you do row operation, this right here cannot be a 0. It could be any number you want, but cannot be 0. So I am switching column 1 and column 3. That's what I have here. I'm switching column 1 and column 3. That's all I did. So I take column 1. I'm taking column 3, put in column 1. I'm taking column 1, put it in 3. Okay, so all I did was switching first column and the third column. That's all I did. So I am column swapping or switching. Again, this cannot be a 0 if I start row operation. Could be any number it wants, but cannot be 0. So I am switching first column and the third column, which I have here. So this right here was used to be in 3. This used to be in 1. Okay, so next, now it is a 1, so we can start with a row operation. Again, it could be any number, but not 0. Okay, so again, row operation. This right here cannot be a 0. It could be any number it wants to be. So I switch column 3 and column 1. That's all I did. I just switch. Column 2, stay. Since this is a 0 already, I just leave it alone. So row 1, row 2, I leave it alone. Now I want this to be a 0, which I have here. So multiply the opposite, which is negative 1. So negative 1 times row 1 plus row 2. Negative 1 times 1 gives me negative 1. Negative 1 plus 1 gives me this 0. Negative 1 times 4 gives me negative 4. Negative 4 plus 3 gives me negative 1. Next, negative 1 times 0 is just 0. 0 plus 2 will give me this 2. Okay? Next, I want this right here, this negative 1 right here. I want this negative 1 to be a 0. One more time, I want this negative 1 to be a 0. So I'm going to multiply this negative 3, the reciprocal of it, which is 1/3. And since there's a negative, I need to put another negative, so become positive. After that, when I subtract negative 1, I get this 0. So negative 3 times negative 1 will gives me positive 3. Divide by 3 gives me positive 1. Positive 1, subtract 1 gives me this 0. One more time. Negative 3 times negative 1 gives me positive 3. Divide by 3 gives me positive 1. 1 subtract 1 gives me this 0. Okay, again, where does this 1/3 came from? I want this to be a 1 so that I can change it to a 0. So reciprocal to 3, which is 1/3. Why do I have another negative? Because I need it to be a positive, so when I subtract, becomes 0. Okay, next, 1/3, negative 1/3 times 5, which I have here. So 5 times 1, negative 1 gives me negative 5. Don't forget the 3. And then plus 2. So 5 times negative 1 is negative 5. The 3 stays in the bottom. And then after that, plus 2, which I have here. Cross multiply the fractions. So negative 5 subtract 1 gives me negative 5. 3 times 2 gives me 6. Bottom multiply. 3 times 1 gives me 3. And then subtract negative 5 plus 6 gives me 1/3, and which I have here. Once this spot and this spot and this spot is 0, here, here, here are 0. Again, if you look carefully, this looks the similar. The upper triangle matrices from LU factorizations, okay? This right here is the upper triangle from the LU factorization lesson, okay? So this is 0, this is 0, this is 0. Since these three are 0, just multiply the diagonal. Multiply the diagonal, which gives me 1, negative 3, times 1/3. So 1 times negative 3 times 1/3. So now I have 1 times negative 3 gives me negative 3. Negative 3 divided by 3 gives me negative 1. However, we have a rule in row operations. So this is the rule right here. When you do row operations to find the determinant, the first rule, when you do row operations, what we did, it doesn't affect the determinant. However, when you switch rows or switch columns, you have to put an extra negative to the determinant. The third rule is when you do row operations and there was any scaling, then you have to bring the scalar along with you. Don't forget the scalar, okay? So when you do row operation to find the determinant, the first rule is it doesn't change. However, that doesn't change the results. However, the second rule is if you switch the rows, switch the columns, you must put an extra negative to the determinant. And the third rule is if you did any scaling, make sure you bring it along. Don't forget the scalar. So in our situation, we did switching the column. Since we switched the column, based on our second rule, when you switch the row or column, you need to put another negative in. So you got to put an extra negative, and that's what I have here. Since we switch or swap the columns, which we did earlier, we have to put another negative, which are here. There's another negative right here. So now negative times negative gives me positive. Okay, one more time. When you do row operation, and if you happen to switch the columns or rows, you must put another negative in. Okay, so now it becomes positive. And as you can see, row operations will give you the same results from co-expansion plus 1, basket weaving, also positive 1, okay, basket weaving, also positive 1, and then row operation still gives me 1, positive 1. Again, be very careful when you do row operation, and if you happen to switch columns or rows, you must put another negative in, okay? You have to put another negative in. So one more time, back to the row operations to find determinant. Number one, row operation doesn't affect the determinant. It will give you the same results. However, if you switch the row, switch the column, you must put another negative in. If you scalar that row operation, don't forget that number that you scale. Don't forget that number. Bring it along with you, okay? So what we did earlier was switching the columns. What we did was we switched the column. Now what happened if we switch the row? Will it come out the same results? So earlier we did switch the columns. Now what if I do switch rows? So again, when you do row operations, this right here cannot be a 0. This right here cannot be a 0. So I am switching row 1 and row 3. I am switching row 1 and row 3. So row 1 now become row 3. Row 3 now become row 1. Why am I doing that? Because this spot right here cannot be a 0. It could be any number but not 0. Okay, so this is 0 already, so we leave that alone. We just need this 5 to become a 0. This 5 right here to become a 0. So we're going to reciprocal this 2, which is 1 over 2. Put the 5 on top, so now becomes 5 over 2. Since this is a positive, I need a negative, so when I subtract, it gives me 0. Okay, so 2 times negative 5 will gives me negative 10. Negative 10 divided by 2 gives me negative 5. Negative 5 plus 5 gives me this 0. One more time. 2 times negative 5 gives me negative 10. Negative 10 divided by 2 gives me negative 5. Negative 5 plus 5 gives me this 0. Okay? Next, negative 5 times 3 gives me negative 15 over 2, which I have here. Okay? And then plus this negative 3. One more time. Negative 5 times 3 gives me negative 15. 15 over 2 plus this negative 3. So I put it right here. Add, subtract fractions. Negative 15 times 1 is negative 15. 2 times 3 is 6. Don't forget the minus. Under multiply. 2 times 1 gives me 2. Add, subtract the top. So that gives me negative 21 over 2, which I have here. Okay. Next. 1/5 times 1 gives me 1/5. All right, negative 5 times 1 is negative 5. Don't forget the 2, but this is a 0, so negative 5 over 2 plus 0 is still negative 5 over 2. One more time. Negative 5 times 1 is negative 5 over 2. Plus 0 is still going to stay as negative 5 over 2. Okay, next we want this 4 right here to be a 0. This 4 right here, we need this 4 to be a 0. So where did I get this 8 and 21? So we're going to reciprocal this 21. So now becomes 1 over 2. Okay, and then the only way to get a 4 is that we need an 8, because 8 divided by 2 will gives me that 4. Or you can think of this way, 2 times 4 will gives me that 8. Okay, so one more time. We need to make this 4 to become a 0. So we are going to reciprocal this 21, 1 over 21. Where the 8 come from? Just think of this, 2 times 4 gives me that 8. Okay, so and this is a negative, so we don't need another negative. So negative 21 times this over here, the 21 will be disappear, will be cancel. All I have left is just 8 divided by 2 gives me negative 4. Negative 4 plus 4 gives me this 0. One more time. Where did I get the 8 and 21 come from? Reciprocal this 21, which will become 1 over 21. Where the 8 come from? Just think of 2 times 4 gives me 8. So this 8 will come back to this 4. Okay, so 21 and 21, this 21 and this 21 will be canceled out. All I have left is just 8 with that minus, so it'll be negative 8. Negative 8 divided by 2 will be negative 4. Negative 4 plus 4 will gives me this 0. Okay, next I will do the same thing. Negative 5 times 8, but there's no canceling here, so I just multiply across. So negative 5 times 8, which I have here, 2 times 21, which I have here. Now just multiply across. Okay, now if you look at this very carefully, you can cancel something. Okay, see this 8 and see this 2. 8 divided by 2 will gives me the 4. 4 times 5 will gives me negative 20 over 21. Okay, one more time. Here we can simplify this down so that we don't get a really big number. So if you look carefully, 8 divided by 2 gives me 4. Okay, 8 divided by 2 gives me 4. 4 times negative 5 gives me negative 20. But don't forget that 21. We did not get rid of that 21. Okay, all we did was just get rid of that 8 and the 2. So 8 divided by 2 gives me 4. 4 times negative 5 which gives me that negative 20. Don't forget that 21. And then after that, plus 1. So where did this negative 20 over 1 came from? After we multiply negative 5, 8 to 21. Okay, and we're adding this 1 right here. We're adding the 1. Now cross multiply. So negative 20 times 1 is negative 20. 21 plus 1 is 21. Bottom multiply. 21 times 1 is this 21. And then add, subtract the top. So negative 20 plus 21 is 1 over 21. And we're going to put this number here. We're going to put this fraction here. And as you can see, this number is 0, this number is 0, this number is 0. Now we can ignore all that and we just multiply the diagonal. Again, this is the upper triangle matrices from LU factorizations lesson. Okay, so since this is a 0, this is a 0, this is a 0, just multiply the diagonal. So 2 times negative 21 over 2 times 1 over 21. And as you can see, these two can be canceled. This 21 also can be canceled. So all I have left is negative 1. However, in the beginning, I did switch the rows. Because I switched the rows, I need to put the negative. I need to put another negative in. So it now become positive 1. One more time. When you do row operation, if you switch columns or switch rows, you need to put another negative in, which I have here. Okay, so this lesson, cofactor expansion, determinant is 1. Basket weaving is also 1. Okay, and row operations also gives me positive 1. Okay, so all three methods give you the same results. Now be very careful when you do row operations. When you do row operations, don't forget these rules. Rule number 1, when you do row operation, the determinant doesn't affect anything. However, if you switch row, switch column, put another negative in. If you scalar, don't forget that scalar. So what is that scalar? Something extra. So don't forget that extra number that you did in the beginning. Make sure you bring it along. Okay? Again, one more time. Cofactor method give you positive 1. Basket weaving also give you positive 1. Row operation also give you positive 1 and positive 1 here. However, with row operations, if you switch column, switch row, make sure you put another negative in, and also here as well too. That's where the extra negative comes from, because you switch column or switch row. Also be very careful with basket weaving. Basket weaving only work for 3 by 3.